Welcome to a brief overview of EnvoZero's RTX. RTX transforms Windows into a real-time operating system. This provides system builders with not only the full Windows experience, but also hard real-time processing capabilities with RTX. So for applications that are in high performance and high precision, they not only have powerful UIs, but also hard real-time deterministic capabilities with RTX. So let's get into this a little bit. So again, Microsoft Windows delivers the full Windows experience with very powerful tooling and a very large software base. However, many high-performance applications require true determinism, and this is where Windows falls short. However, when you combine Windows and RTX, again, RTX transforms Windows into a real-time operating system. So you still get the powerful Windows experience. However, now you have a separate real-time scheduler to schedule all of the real-time as far as functions that you need in your application. So this in itself provides a great amount of value for a lot of applications. And RTX has actually been delivering this real-time transformation for over 10 years and over 1 million deployments. So as you can see, this is a platform that is advantageous for a lot of different high performance as well as high precision applications. So let's get into one example to help illustrate this point. So if you look at this typical example, so if you see here, this one is using a typical commercial off-the-shelf hardware with a dual-core x86 processor, and we have Windows loaded on both the cores. So Windows is still providing a very powerful user interface for this application. However, in this case, to deliver the real-time needs, we have these plug-in cards. So here we have, for example, DSPs, but this can easily be FPGAs and ASICs. So these plug-in cards are delivering the real-time components. Although this is a very capable system, there's a lot of challenges that go along with this type of system. So if you look, there's first proprietary hardware. These plug-in cards are based on, for example, DSP and FPGAs. So although you're using nice commercial off-the-shelf motherboards with x86 processors, you have proprietary boards, which leads to a lot of times complex tooling. A lot of these plug-in cards usually have their own tool sets, their own compilers, their own operating systems. This leads into separate code bases, sometimes separate development teams. So there's a lot of software to manage and integrate. Also, performance becomes an issue because although Intel and AMD's roadmaps are quite advanced, sometimes these DSPs or plug-in card roadmaps may not be as advanced as you'd like. And this leads into scalability. You know, again, while you're using commercial off-the-shelf hardware, which is scalable, these plug-in cards are sometimes limiting because, again, you're tied to their roadmaps and how often they do releases. And again, they may not scale as much as you'd like. And also, because they're using plug-in slots like PCI, you may be limited by the number of PCI slots in your hardware. So this creates several other issues. For example, first one is high BOM costs. So you have a lot of moving pieces here, not only from a hardware and board perspective, but also from a tools perspective. So you have high engineering costs as well. Performance is an issue because, again, you're tied to multiple architectures, multiple roadmaps. That can be constrictive. Scalability is an issue, again, tying to the multiple architectures in your system. And then finally, time to market. So because you have so many components when it comes to hardware as well as software to manage, this a lot of times results in slips in schedule and eventually compromises your time to market. Okay, so let's look at the same system and how, when we add RTX to the equation, we can actually impact things. So if we look here, we have the same exact system, but now once we load RTX, we actually take one of the cores, and now we have Windows on one of the x86 cores, and we have the RTX real-time scheduler on the second one. So what this allows us to do now is move any real-time processing that was done on these proprietary plug-in cards over to this dedicated RTX core. So by moving that functionality onto this now real-time core with RTX, we can eliminate the need for this proprietary hardware. And so as a result, we have the same application, same capabilities running on standard commercial off-the-shelf hardware, standard x86 multi-core processors, still leveraging Windows, and now RTX is delivering the true hard real-time performance. So we've eliminated proprietary hardware in the whole system as well as the tooling. So we've impacted our costs by lowering our BOM costs, lowering engineering costs by streamlining everything, having a single code base, all developing under one development environment, that's Visual Studio. Performance is unbounded now because we're now only tied to one roadmap, as that's Intel and AMD's multi-core roadmap, which are quite advanced. scalability, although this is a dual core, you can easily scale this up to be quad 8, up to a 32 core system, because RTX supports something called symmetric multiprocessing. So you can actually have a single scheduler across multiple real-time cores. And then finally, time to market has been impacted because, again, we have simpler hardware, simpler tooling, simpler code bases as far as using commercial off-the-shelf hardware, no custom boards. So that all results to a shorter time to market. Okay? So coming back to this graphic here, we're again, Windows providing the powerful Windows experience. When you combine it with RTX, transforms it into a real-time operating system. So although this is very powerful in itself, this is actually one component of a much larger platform, and that's the RTX RTOS platform. So we already talked about multi-core x86 hardware as being the foundation of it all. It's all based on this standard Intel and AMD processors. Here's Windows plus RTX delivering the RTOS performance. What we haven't talked about yet is communications. So in this case, for real-time Ethernet, we'll use EtherCAT or Profinet. This can be any number of other real-time communication protocols. That's all part of the platform. As a customer, you will implement your intellectual property and application here at the highest level of the platform, leveraging all these components below, all developing under a single development environment, and that's Visual Studio. So that summarizes an overview of RTX, and we got a little bit into the RTOS platform. So in other videos, we'll go into more detail about the components of this platform. So if you go to this website, you'll find those additional videos, and hopefully you tune in, and thanks again for the time.